Saturn. The very name conjures up images of a celestial gem, adorned with a breathtaking system of rings. It's a planet that has captivated astronomers and dreamers alike for centuries. But Saturn is far more than just a pretty face. It's a dynamic world, a gas giant with a turbulent atmosphere, a family of intriguing moons, and a history that holds clues to the formation of our entire solar system. Saturn's rings, visible even through a small telescope, are its most iconic feature. These rings are not solid, but rather a vast collection of ice and rock fragments, ranging in size from dust grains to houses. They stretch out over 175,000 miles, yet are remarkably thin, averaging just 30 feet in thickness. Imagine a sheet of paper stretched across a football field. That's how thin Saturn's rings are in proportion to their width. Saturn is a giant, second only to Jupiter in our solar system. Its diameter is almost 10 times that of Earth. If Earth were a nickel, Saturn would be a basketball. Its volume could hold over 700 Earths. But despite its size, Saturn is surprisingly light. In fact, it's the least dense planet in our solar system. If you could find a bathtub big enough, Saturn would float. This low density is due to Saturn's composition, which is primarily hydrogen and helium, the lightest elements in the universe. These gases swirl in a turbulent atmosphere, driven by powerful winds that can reach speeds of over 1,000 miles per hour. Storms rage in Saturn's atmosphere, some larger than Earth itself. Saturn's atmosphere is not just a chaotic jumble of gases, it has its own intricate structure with layers of clouds composed of ammonia ice, water ice, and ammonium hydrosulfide. These clouds create the beautiful banded patterns we see in Saturn's atmosphere. Saturn boasts a diverse family of over 80 moons, each with its own unique story to tell. Among these, Titan stands out as a world of particular interest. Titan is larger than the planet Mercury and is the only moon in our solar system known to have a dense atmosphere. This atmosphere is so thick that it obscures Titan's surface from our view. Titan's atmosphere is primarily composed of nitrogen, much like Earth's. However, it also contains significant amounts of methane, which forms clouds and even rain. The surface of Titan is a frigid negative 290 degrees Fahrenheit. At this temperature, methane can exist as a liquid, forming rivers, lakes, and even seas. Titan is a world of both familiarity and alienness. It has weather patterns with methane rain carving channels into its icy surface. It has volcanoes that erupt with water ice instead of lava, and it has vast dune fields, shaped by winds blowing across its alien landscape. While Titan is a world of cold methane, another of Saturn's moons, Enceladus, harbors a secret beneath its icy surface. Enceladus is a small moon, only about 310 miles in diameter, but this tiny world has captured the attention of scientists due to its remarkable activity. Geysers erupt from Enceladus's south polar region, spewing water vapor and ice particles hundreds of miles into space. These geysers are evidence of a vast ocean of liquid water hidden beneath Enceladus's icy crust. The presence of liquid water, along with organic molecules detected in the plumes, makes Enceladus a prime candidate for the search for extraterrestrial life. The energy driving these geysers is thought to come from tidal forces generated by the gravitational pull of Saturn. As Enceladus orbits Saturn, its interior is stretched and squeezed, creating friction that generates heat. This heat keeps the subsurface ocean liquid and powers the geysers. Saturn's rings are not just a static, unchanging feature. They are a dynamic system, constantly shaped by the gravitational influence of Saturn's moons. Among these moons, the so-called shepherd moons play a crucial role in maintaining the structure of the rings. Shepherd moons are small moons that orbit within or near the rings. Their gravity acts like a shepherding force, confining the ring particles and preventing them from spreading out. One of the most famous examples is the moon Prometheus, which orbits just inside Saturn's F-ring. Prometheus's gravity creates waves and channels in the F-ring, giving it a braided appearance. Another shepherd moon, Pandora, orbits just outside the F-ring, helping to keep it confined on its outer edge. The F-ring is one of the most intriguing features of Saturn's ring system. It's a narrow, faint ring located just outside the main A-ring. Unlike the other rings, which are relatively smooth, the F-ring has a complex, ever-changing structure. It features kinks, braids, and clumps, all sculpted by the gravitational influence of its shepherd moons. The F-ring's intricate structure is a testament to the delicate balance of gravitational forces at play. It's a constant reminder that even in the vastness of space, small objects can have a profound impact on their surroundings. The F-ring's dynamic nature makes it a fascinating target for observation. Scientists continue to study its intricate features, hoping to unravel the secrets of its formation and evolution. Saturn's moons are not just passive bystanders. They engage in a complex gravitational dance, influencing each other's orbits and shaping the rings around them. This interplay of gravitational forces creates a dynamic and ever-changing environment. One example of this cosmic dance is the relationship between the moons Janus and Epimetheus. These two moons share nearly the same orbit, with Janus slightly farther from Saturn than Epimetheus. Every 4 years, the two moons approach each other. Instead of colliding, they exchange orbital positions, with Janus moving slightly closer to Saturn and Epimetheus moving slightly farther away. This gravitational swap ensures that the two moons never collide, maintaining a stable co-orbital relationship. Saturn's atmosphere is a realm of swirling gases, powerful winds, and enigmatic storms. While we have learned much about Saturn's atmospheric composition and dynamics, many mysteries remain. One of the most enduring mysteries is the origin of Saturn's powerful winds. These winds can reach speeds of over 1,000 miles per hour, far exceeding anything observed on Earth. Scientists believe that these winds are driven by heat from Saturn's interior, but the exact mechanisms are still not fully understood. Another puzzling feature is the presence of a hexagonal jet stream encircling Saturn's north pole. This hexagon is a long-lived feature, first observed in the 1980s. The precise cause of this hexagonal jet stream remains a subject of ongoing research. Saturn's rings are a source of endless fascination. Their origin, composition, and dynamics have been the subject of scientific inquiry for centuries. Today, thanks to spacecraft missions like Cassini, we have a much deeper understanding of these celestial wonders. We now know that Saturn's rings are not solid structures, but rather a vast collection of ice and rock fragments, ranging in size from dust grains to houses. The rings are constantly being replenished by material from Saturn's moons, which are bombarded by micrometeoroids and other debris. The rings are also constantly evolving, with collisions between ring particles and the gravitational influence of Saturn's moons shaping their structure and dynamics. Saturn is more than just a beautiful planet with rings. It's a window into the history and evolution of our solar system. By studying Saturn's atmosphere, rings, and moons, we can gain insights into the processes that shaped our planetary neighborhood. Saturn's composition, primarily hydrogen and helium, reflects the composition of the primordial solar nebula from which our solar system formed. Its rings provide a glimpse into the processes of accretion and differentiation that occurred in the early solar system, and its diverse family of moons, each with its unique geological history, offers a natural laboratory for studying the processes that shape planetary bodies. By unraveling the secrets of Saturn, we are deepening our understanding of our own cosmic origins.